Hello class, so Unit 5, Lesson 6, Sine Law Review and Ambiguous Case. Number 1 says to summarize a sine law and when you can use it. So you have probably seen this in grade 10. And for sine law, you can use this on any kind of triangle. So it can be a right angle triangle or it doesn't have to be a right angle triangle. So for now, I'm just going to draw a general triangle with the coordinates A, B, C. So we say that the one across from coordinate A has the line segment A. So we say that this is A, or another name for that it is line segment BC. This will now be B because it's across from the coordinate B, and this will be C, or it could be called line segment AB. So I've used the highlights to show you that the line segments correspond to the angle across from it. So it says when you're going to use it is when you're given a pair of opposite angle to the side. So let's say you have this angle B and you have this side B. And let's say you are missing this part. But then you must have this side. So that's kind of how it works. So I'll write that down. So the equations I'm going to write is one version where we have sine A divided by A is equal to sine B divided by B, and then sine C divided by C. So although there are three parts to this equation, what I usually do is look at one part. So let's say I might be looking at that part, or I might look at these two together, or I might be looking at these. But at the root of it, it's like I'm looking at one equation at a time. And generally, you're looking for the angle when you're using this version. Another way you can write it is that you can write all of this in the reciprocal version. And because you have the sides in the numerator, you could say that you are looking for the side. So you're using this version when you're looking for the side. But in my case, I don't like to remember a lot of equations in my head. And so what I usually do is like stick to one equation and I just remember it. So let's say if I remember this, I know that I can just cross multiply, and eventually I'm just gonna either end up finding like an angle or a side. So what I recommend is maybe remember this, and then you can just make sure that you're finding the variable that you are interested in. So I basically wrote, or you can just use one version and do cross multiplication to find the missing variable. Okay, so just written in words. Now let's go to question 2. So question 2 says to find side BC. Well, BC is this one right here. I noticed that I have a corresponding angle of 93 degrees. Meanwhile, I have 58 degrees, which corresponds to this side right here. But I don't have that side, so I'm not going to put arrows on that. But I do have a side length of 16 and this other acute angle. When I take a look at this triangle, I remember that any triangle adds up to 180 degrees, and that is according to sum of angles in a triangle theorem. So we're going to do 180 degrees minus 58 degrees minus 93 degrees equals, you will get 29 degrees there. So I'm going to write 29 degrees there, and that is according to sum of angles in a triangle theorem. So when you look at what I've highlighted, I basically have an angle that has its corresponding side. So I have that. I have the angle, but I don't know what its corresponding side is. Keep in mind, this is not a right angle triangle, and we can't use SOHCAHTOA, and that's why I didn't go to SOHCAHTOA for this question. And so we're going to try to use that sine law, and I'll write one version of it. Let's say A over sine A equals B over sine B. In this case, I chose this version because I'm looking for a side length. But again, like I said before, you could just use either or. You're going to still get the same answer. So this is my original equation. Actually, I'm going to change the way I write this. If I write it so that it's A over sine A equals A over sine B, just as like that, I might end up writing the wrong letters in, rightfully so. So I'm going to just label this as B, this is C, and this is A. So what I'm going to do is, well, I have the angles of B and side length B, so I'm going to just write it and adjust it so that I have B and divided by sine B, because that's what I have. And I have to solve for A, and I have angle A. So basically, you are playing around with this equation, but you're making it so that you're working with the one that you're using for this question. Or you could have had it the other way around, but the way I end up subbing it later, this is the way I've subbed it in, so I'm just going to leave it like that. So for example, my side length is 16, sine is angle with 29 degrees. My A, I don't know. And then for sine, I have sine 93 degrees. So we're going to cross multiply. And I will be left with 16 sine 93 degrees is equal to A sine 29 degrees. I'm going to divide by sine 29 degrees and divide by sine 29 degrees. Keep in mind, you could have said that A is also line segment BC. You could have written it that way as well. That cancels those out, and A is equal to whatever that works out to be. And so A is equal to 33.0 units approximately when you put that in the calculator, or you could have written this as line segment BC. And because the question asks you to find side BC, I'm just going to rewrite it so that it says BC is equal to 33.0 units. It's really the same thing. Okay, so for question 3, and before I go to question 3, at the very end of Unit 5, Lesson 7, which is like the end of this whole package, I ended up drawing like a pathway flow chart. And so how you read it is you have a triangle, and if you have a right angle triangle, you can use SOHCAHTOA or Pythagorean theorem. And after that, after the fact that you're going to use, for any triangles, you can use the cosine laws and the sine law, which we go over in Unit 5, Lesson 6 and Unit 5, Lesson 7. So I just want you to be aware of this flow chart, which is available under Unit 5, Lesson 7. So that you realize that it's only when we have a right angle triangle that we can use these two. But otherwise, if it's not a right angle triangle, you need to skip all of those and then go to these options to solve. Another thing to keep in mind is that if you have a right angle triangle, yes, you can use SOHCAHTOA, Pythagorean theorem, along with the cosine and sine law. That's something else to keep in the background. But remember, you cannot not use the SOHCAHTOA or Pythagorean theorem if you in fact have a non-right angle triangle, meaning a triangle that does not have a 90 degrees. So when I go to question 3, like a fact check I go through is, okay, this is not a right angle triangle. I can't use SOHCAHTOA. I can't use Pythagorean theorem. Okay, next, I am going to use what? Well, because I can't use SOHCAHTOA, I'm going to use that sine law, and I'm on the sine law page, so that probably makes sense. But I have basically these corresponding angles and sides, and these are corresponding angles and sides. So for now, I'm just going to write sine A divided by A is equal to sine B divided by B. So because this isn't really labeled, let me label it. Well, the things that I have, well, I'm just going to label that A. So this becomes B. Well, this is my B, and therefore this is my B. That leaves that to be C. We usually use capitals for the angles and then the lowercase for the sides. So let's plug in. My angle is, so I have sine 55 degrees divided by 9 is equal to sine of x divided by 10. We are trying to solve for x, which is right there. We're going to cross multiply. We get 10 sine 55 equals 9 sine x. We're going to divide by 9 on both sides. We get sine x equals, I like writing my x on the left side, so that's how I've moved it. Doesn't really change anything. So I have 10 sine 55 degrees divided by 9. Well, with that, I need to get x by itself, so I'm going to take sine inverse of both sides. So x is equal to 66 degrees, approximately. And I have answered the question of finding angle x. But wait, let's take a look at the question. We found that the x is equal to 66. Does that make any sense? So when we actually look at the triangle very carefully, we notice that it's definitely not an acute angle. It's an obtuse angle, and so we need to do one more step. So as step 2, I'm going to say, but wait, when we're using sine law, we need to do a check. And you'll see why in the next question. Right now, x is an obtuse, but we got an acute as the answer. Well, why did that happen? Well, let's see. According to our cast, which we have been like really drilling about in the last couple lessons, these are the regions where sine is positive. So that means my terminal arms are going to lay here and there in quadrant 1 and 2 respectively. So with the angle I got, which is 66 degrees, this would go right here at 66. But keep in mind that these two, I have the same sine trig ratio for when I have this and this. So when this is 66 degrees as well, my terminal arm for this other angle is going to be 180 minus 66, and therefore this is going to be 114. So basically my theta 1 is equal to 66 degrees, and my theta 2 is equal to 114 degrees. But between the two, and when we look at this triangle, and based on the visual, my angle should have been an obtuse, which means that my answer has to be an obtuse. Therefore, what this means is that I am actually going to unhighlight this, and I have to actually conclude that therefore, because my angle has to be an obtuse, my x was found by doing 180 degrees minus 66 degrees, and therefore x is equal to 114 degrees. So we had to do this check and double check and make sure that our x actually made sense with our triangle. Number 4, sometimes solving for the angles using the sine law. The calculator gives you the acute angle when the problem actually requires an obtuse angle, like in one of the questions above over there. Why does this happen, and why don't you need to worry about this scenario with cosine law? So I'm going to basically draw the cast again, but that's because... because when you sine inverse a positive number, you get an acute angle which lays on quadrant 1, because quadrant 1 has all the acute angles, right? So according to my cast, this is where my sine ratios are positive, and again, you get an acute angle in quadrant 1, but you can also get an obtuse angle in quadrant 2. And therefore, keep in mind when you're creating a triangle, it's totally acceptable for you to get an acute angle or an obtuse angle when making a triangle. And therefore, what happens is because an acute angle and an obtuse angle are both acceptable angles when you're creating a triangle, that means you have to double check and make sure that you're getting the angle that you actually want, like we saw here. And so basically, anytime you're doing sine inverse, sine inverse the positive, you have to always make sure that you check and make sure you're dealing with the correct one. However, that's not necessary for a cosine, because when you take the cos inverse of a positive number, so you basically get an acute angle as well, because for cosine, you have basically an angle there, an angle over there for cosine. And therefore, you're dealing with an acute angle, but the other angle that you get is not an obtuse, but you get a reflex angle instead. Because if you have an angle here, that's the type of a reflex angle, because a reflex angle is an angle that is larger than 180, but less than 360 degrees. So which will not create a triangle for a real life scenario. And therefore, that's why you wouldn't have to worry about it as much when you're taking a cos inverse of a positive number versus when you're taking a sine inverse of the number. So really quickly, I was kind of curious about what happens when you take a sine inverse of a negative or cos inverse of a negative, just out of curiosity. So I'm realizing that if I take sine inverse of a negative, I'm right here, which means I always get a reflex angle, and so the answers won't make sense anyways for when you're making a triangle, so you don't have to worry about that. When you take a cos inverse of a negative number, you get an obtuse angle and a reflex, and so that means only the obtuse makes sense when we're talking about it as a triangle. And so again, it seems that it doesn't really matter. It's only the sine law that you need to worry about when you are considering whether it makes sense for a triangle, because only for when you're taking sine inverse of a positive are you getting answers that make sense for a triangle, like an acute versus obtuse, and so you need to do that check.